Well, it's difficult to say exactly because we can't even gauge what type of creature this is. They look like they shouldn't be able to swim. They look like a big fish head with wings. And very, very clumsy. But when you watch them swim in the water, they are very acrobatic. They can steer with precision because of the way that it can undulate these two big fins. One of the things with sunfishes is that they change body form all through the life. So from tiny little larvae and up to massive adults, they look very different. So imagine this massive, massive fish comes from a tiny little larvae that is about 2 millimeters long, and it looks very much like a pufferfish larvae. And it actually does have a precursor to a tail, just like normal bony fish have. Now, very quickly, they lose that tail, or it starts to disappear, or the body will just basically absorb it as it develops. And so it goes from this elongated little larvae stage to a round little Pokémon with spikes. Everything about these fish is just so deliciously mysterious. It's just there's so many unknowns and they're so different to other fish. So yeah, I kind of fell backwards into it, I guess you can say. But once I sort of got to know these fish, it's just impossible to look away.
Hey there, trainers. You're listening to Season 2 of Bio-Diversity, the podcast about pelagic Pokémon and coral curiosities, each episode bringing you the best in flippin' fun fish facts straight to your ear holes. It's like we're the delivery drivers of peer-reviewed aquatic science, the Grubhub of fish food for your mind, the DoorDash of dope decapods. Here on the show, we examine the weird, wacky, and wonderful diversity of life that lives under the sparkling waters of our blue world. Using science as our guide, we dive deep into both the common and the rare, the exotic and the ugly. So tune in for the Tridacna, and hang around to mingle with the mola. Let's descend. Welcome back to Biodiversity. Today on the show, we're getting weird. As in, you can't talk about the weird, wacky, and wonderful parts of the ocean without talking about one of the most bizarre groups of fishes that has ever gracefully wobbled through it, the sunfishes. You may also know this fish commonly as the mola, or mola mola. But as we will learn, it's not just one fish. There are actually 5 separate fish species in this bizarrely awesome cluster. This group of fishes is so incredibly wacky that many people, beachgoers and fishers alike, may not even immediately recognize it as a fish.
I don't know what this is, but Jay says it's a big sea turtle.
Oh, look, a baby whale.
It's a baby whale, man. Holy we are witnessing a baby whale right here, dude. Holy
It is a strange creature, honestly, more akin to a real-life Pokémon than it is any other living animal. So, in a series first, today it's not just my singular voice here to tell you all about them.
My pleasure, absolutely. As you know, this is my favorite topic to talk about.
Today, I am so lucky to be joined by Dr. Marianne Nyegaard, one of the most exciting people on this planet when it comes to talking sunfishes.
So my name is Marianne Nyegaard, and I'm Danish, hence why my name is so weird, I guess. People in English-speaking countries call me Marianne, and that's also fine. And I'm a research associate at the Auckland Museum at the moment here in New Zealand, and they support my research on ocean sunfishes. I also have a paid day job, and that is I work in compliance in the fishing industry in the Antarctic.
Dr. Nyegaard is one of the world's leading experts in the sunfish space, and her story of how she arrived to be such is just about as intriguing as the fish itself.
Well, I mean, in my former life before sunfishes, I never ever thought or dreamed of this kind of interest in this fish. It wasn't really a bleep on my radar. So it's very coincidental, really, how I fell into the research. Previously, I mean, I went to university, in early life up in the north of Norway, and was very interested in polar regions, and worked a bit in the fishing industry, and ended up in Australia, where I worked in marine environmental consultancy. And I just happened to have a friend who came through from the States, actually. She was in Southeast Asia and said, come up and visit. And Australia is not far away. So we ended up meeting in Bali on a little island called Nusa Lembongan. And I went diving there, of course, and it was beautiful. And I noticed all of these pictures everywhere of sunfishes and sort of dive operators offering these sunfish tours. Before then, I had not really thought much about sunfish at all. I knew of them from when I was little, and my mom took me to the Natural History Museum, and these massive odd fish were on the wall there. And I remember thinking, how can that even be an animal? And so up in Indonesia, I started asking around, where do these fish come from? And nobody really knew. And so I thought, oh, that would be a good PhD topic. To understand more about these fish, because this quite large dive industry was kind of halfway relying on the influx of these fish for, to sell dive trips. And people do come from all over the world to see them. And then there was this kind of notion that there were fewer and fewer each year, and the divers had a really, detrimental, bad effect. And so I went home and quit my job and started a PhD on these sunfishes in Indonesia. So my interest really started in the space of understanding something about sunfishes so that a management plan could be put in place around the diving. And little did I know what an amazing world I just sort of swam into, because everything about these fish is just so deliciously mysterious.
Now, I've heard of plenty of fish being delicious, but deliciously mysterious. Now that has me intrigued. So let's start at the beginning. What the heck even is a sunfish?
So first of all, we are in the realm of bony fishes. So what people would consider a normal fish. So not a shark and, not a ray, but like a normal bony fish, like a mackerel or something. We're in that realm. These fish can get enormously huge. And when they strand, I have heard the brilliant descriptions, like people saying, I have seen a small whale, or, something that they can't pinpoint what it is. So the body form is different to any other fish in that it is round like a plate, or think about like maybe a suitcase, slightly elongated. And then it has a fin on top and a fin on the bottom, and these are enormous, like sails. And then on the back, where a normal fish would have a tail, it just has this little rounded flap, and it can't actually gain any thrust with that. It's only like a little steering device, and it's called the clavus, and it is from Latin, and it means rudder. So like on a ship you would steer with, but you don't get any forward motion from it. So instead, it swims with these two massive fins that have like wings. And so if you've seen a penguin fly underwater, it's basically, that same kind of, it moves these fins in relation to the body, and then it gains thrust to go forward. They look like they shouldn't be able to swim. They look like a big fish head with wings. A very, very clumsy.
You can find an image of the ocean sunfish, the quintessential mola mola, gracing the cover of this episode, but I encourage you to check out the show notes as well, where you'll find images of all 5 species that fall under today's discussion. These 5 fish are a diverse crew, but there are a few things that they are all, mostly, well known for. Firstly, most of these species are huge. Most adult individuals, with some exceptions, are easily as large, usually larger, than a person, averaging around 1.8 meters, or 6 feet, in length. Many sources online will tell you that sunfishes are the world's largest bony fish, but what they technically mean is the heaviest.
They also grow much, much bigger than other fish species. So when you think about the biggest fish you can think of, you might think of a tuna or a massive sturgeon. And we're talking hundreds of kilos here. But when you look at very large sunfishes, we're talking a ton or more. And the heaviest sunfish that has been weighed is 2.7 ton.
2.7 ton, meaning, of course, roughly 2,700 kilograms. And for us non-metric users, that's around 6,000 pounds.
So it's like a small car.
And that's not just any car. That's heavier than almost any standard SUV. Heavier than a Jeep Wrangler. Heavier than a Ford F-150. In a fish.
The 2.7 ton was a recent data point from the Azores where they recognized how important it was to actually weigh this. And this is now in the Guinness Book of Records. It's the heaviest fish ever weighed, bony fish, I should say. And we don't really know how big they actually can, what weight they can reach, because the really big fish are not often seen by humans. And when they are, who has a scale just there that they can weigh them on?
These fishes can be, and I say this scientifically, chonky, boys and girls. Again, that is a generalization. There is always an exception to the rule, which we'll get into later, but this chunkiness is definitely a part of their charm, as many divers and ocean lovers include molas on their bucket lists of animals to see in their dive careers. So much so that the dive industry in Bali, as Marianne mentioned, relies on a seasonal influx of the fishes to drive tourism. The key word here being seasonal. Large populations don't stick around all year long. So, in order to find out where these sunfish, commonly thought to be the species mola mola, were coming from before their arrival in Indonesia, she turned to genetic sampling.
So I had just started my PhD and I was in Indonesia and trying to collect little tiny bits of tissue from these fish for genetic analysis. And what I was interested in knowing was where this seasonal phenomenon of sunfish coming into the reefs, where did they come from? Were they part of Indian Ocean population, or were they more associated with the Pacific?
To try and find out, in addition to the samples that she collected from Indonesia, she worked with fisheries in Australia and New Zealand, places where mola mola are also known to be, to acquire genetic samples to compare to.
And I would just get these tissue samples in the mail, like in tiny little vials. And so at some stage I had amassed a certain amount of samples, and I flew up to Denmark because my sister is a geneticist.
Here, in her sister's lab in Denmark, she would get her first taste of the delicious mysteries of the sunfish.
I mean, there was so much that happened in that first few months, because first up, we could see that the fish in Bali were not mola mola like we thought. So they belonged to another species that at the time was called mola ramsay, or so we thought. And then the other thing was that when we sort of looked at Australia, where everyone at the time thought that all the sunfishes there were probably mola mola, it turned out that there weren't any mola mola at all. There were a lot of these mola ramsay, and then there was another species called Masturus lanceolatus, and that is a sunfish species that's really overlooked, and it has like a little extension on the back end. It's called a sharp-tailed sunfish, and so we saw a heap of them. So it was like crazy. The whole situation just changed, that we weren't just dealing with one species. And the other thing was that there was a cluster in there that we couldn't tie to anything.
And that cluster, that nagging, mysterious genetic unknown, it set the not quite Dr. Nuko down a very different path.
And so there was at the time, some Japanese researchers had looked at this and they thought there was an undescribed species. And that was this one. I kind of sat there thinking, that would be fun to describe a new species. How hard can that be? And I didn't know much about taxonomy at the time. And had I known, I don't think I would ever have done this work. So sometimes ignorant is bliss, because I thought, All we got to do is find it.
Right. Just find a physical specimen of a fish of a species as yet undescribed by science out there in the huge blue ocean. Super easy, right?
And so I set out to try and find something I didn't know what it looked like. We knew it was in New Zealand, so I jumped on social media and trawled through pictures of what do people see in New Zealand. And I mean, it took years. And I worked with people in Japan as well who was also looking into this. So at the end of the day, I managed to trawl through so many pictures and kind of put them in piles of how I thought these species looked like, because there's more than one in New Zealand as well, it turns out. Anyway, so I was sitting there waiting for a fish that would become available to me that was from this unknown species that I could both have in my hands or touch and also get a sample from, so I could run the genetics to confirm that what I thought was this was actually what we thought it was.
I love this because it really goes to show the duality of science. Sometimes it looks glamorous in white lab coats or adventuring out into the field, and other times it's scrolling through social media and hoping against all hope that you find a fish.
And that happened one day. Somebody contacted me saying on social media there was a stranding in New Zealand and the fish was still alive. And I jumped on social media and tracked down the person who had posted it and called him up. I mean, it's amazing what you can find out of people. And called him up and said, can you is the fish dead? And he goes, yes. And so I said, okay, well, I'm coming over. Can you make sure it doesn't wash out? And he just laughed and said, there's no way. This beach is full, it's just made out of rocks. And so it's like a reticulated beach. You can't do anything there. You can walk on it, obviously, but you can't drive on it. You need a quad bike and all sorts. But I ended up going over there and basically jumped on a plane, flew over there and arrived in the dark, of course. And this guy was really kind. He took me down to the beach in his car and just, he had the headlights on. And that was the first time I ever saw this new species. And the flesh was in the moonlight on a remote beach in New Zealand. It was so unreal. That allowed me to run the genetics and also have a really good look at the morphology and how this species exactly looked like. And together with the team in Japan, we managed to basically sort out what's called the genus Mola, the Mola genus. So all the species that sit in that group called Mola. We called it Mola tecta from the Latin tectus, which means disguised or hidden. And that is a nod to the fact that this fish had managed to just fly under the radar for all of these years and just basically hide in plain sight. It's not like no one had ever seen it before, but just no one had realized it wasn't a mola.
So, yeah. Of the 5 species of sunfish out there, Dr. Nuko is responsible for helping to discover one of them. And she's talking to us here today on the show. Are you a little starstruck? 'Cause I'm a little starstruck. These days, she spends her time tirelessly investigating and researching this misunderstood fish, splitting her year between researching them and going out on boats to work in the fisheries industry in the Antarctic. It's safe to say that a lot of her life revolves around fish in one way or another, and the sunfishes are, in her very own words, her favorite thing. From physical superpowers to adorable aesthetics, there are so many reasons for this. And that awesomeness starts even as you begin to talk about how these fish are named. If you want to get taxonomically technical, which you know I absolutely do, the 5 known species we're talking about all fall under the family Molidae, which fall under 3 genera, Mola, Masturus, and Ranzania. And I'm sorry, I can't help myself, you know I have to list them all off. For the sake of accuracy, of course, not just because I'm a fanboy. You understand. First off, there's the most well-known of the species, the ocean sunfish, or Mola mola. As previously mentioned, if you've ever heard of sunfishes before, this is likely the species you've seen or heard about. A true classic. Then there's the species that holds the weight record, the giant or bumphead sunfish, Mola alexandrini. These absolute units are large, tanky, and just a little bumpier than mola mola. And then, of course, we have the mysterious and sleek hoodwinker sunfish, Mola tecta, rounding out the mola genus and hiding from the world until 8 years ago, when Dr. Nuko first laid eyes on it on that fateful, moonlit New Zealand night. The next two, though they are not part of the mola genus, still are molids. They share the same body form. Breaking the mold of completely lacking a recognizable tail, we have the sharp-tail sunfish, Masturus lanceolatus, with a funny little tail protrusion off the clavis that it barely has. And lastly, we have that exception to the molas are big rule, with Renzania laevis, the slender or dwarf sunfish, who only get up to about 1 meter or 3.3 feet in length. But size isn't everything, and this little cutie is the most colorful of the 5, with some specimens having brilliant silvers, blues, and browns. I admit, I still have to catch myself sometimes when talking about sunfishes, because I will often use the term sunfish and mola interchangeably, which works well but is not technically correct. So, I'm going to start using the broader term from now on, molids, because being technically correct is in fact the best form of being correct. But to put a fun spin on the pedantics of this naming, I would be remiss if I didn't mention a few of my favorite molid naming facts. The very name, molid, comes from the Latin root word mola, which means millstone. Sort of makes sense. They are large and gray and circular, so our ocean sunfish being named millstone, mola mola, kind of makes sense. But if you get into common names around the world, things get pretty fun. They are called sunfish in English because of an intriguing behavior where they lay on their side on the surface and sunbathe. More on that later. In French, though, they buck the sunfish name, instead being called poisson lune, or moonfish, a convention that other languages follow, including Dutch, Spanish, Portuguese, Hungarian, Greek, and Norwegian. Of course, English just had to be different. In Taiwan, they can be referred to as the toppled car fish, which is objectively fantastic, and in Danish, there is klumpfisk, or lumpfish, though perhaps my favorite mola name comes from Germany, where many refer to it as schwimmender Kopf, or, quite literally, swimming head. And hey, the fish certainly fits the bill. Das ist ein schwimmender Kopf. Now, interestingly, these fish don't look like a schwimmender Kopf for their entire life cycle. They actually start out looking way more like a normal fish than we might anticipate.
Yep. So, when I started studying sunfishes, I was totally focused on the big ones. And I think many people sort of go, oh, these cool fish, and they're really big. And that's one of the things they're very well known for. And it wasn't until sort of I got more into the nitty-gritty of the topic that I realized how cool the early life stages are. So imagine this massive, massive fish comes from a tiny little larvae that is about 2 millimeters long, and it looks very much like a pufferfish larvae.
Imagine a tiny, little, elongated pufferfish just a little less wide around than the width of a typical headphone jack. Or, if that reference unduly ages me as a person and you've lived your whole life with Bluetooth, just a little bit wider around than the diameter of a strand of spaghetti. Small.
And it actually does have a precursor to a tail, just like normal bony fish have. Now, very quickly, they lose that tail, or it starts to disappear, or the body will just basically absorb it as it develops. And so it goes from this elongated little larvae stage to a round little Pokémon with spikes.
Side note, for those nerds out there like me that are familiar with Pokemon, at this stage it honestly looks a little bit like the world's tiniest quillfish. A tiny little spiky ball.
And they develop all of these little spikes, presumably as protection. And their eyes are enormous, and they are the cutest thing. And then They grow more and more in this round phase, and then they start to go into what I like to call the Oreo stage. And that is basically where they become flat and the spikes start to disappear, and they look like a little Oreo with wings. They're very round and very, very cute. And I imagine that everything in the ocean would like to eat them at this stage. And this is when we do find them in the stomachs of, for example, tuna. They like to eat them. And then they start to elongate the other way instead. And so they take on the shape that we know as sunfishes. And they reach this stage around 7 to 10 centimeters.
And from that stage on, they take their growth very seriously. Over the course of its development, the species Mola mola will increase their weight nearly 60 million-fold. This is quite potentially the most extreme size growth of any vertebrate that we know of. And this growth happens remarkably fast. At least presumably. No real data actually exists for how quickly these fish can grow in the wild. However, one mola mola in captivity at the Monterey Bay Aquarium in California grew over 364 kilograms, that's over 800 pounds, in just 14 months. It got so big in just over a year that it outgrew its million-gallon tank and had to literally be airlifted out of the aquarium in order to be released into the wild. Mola delivery by helicopter. You know, I do have very few regrets in life, but not seeing this behemoth fly might be counted among them. So even when we ask basic questions like, how fast do the fish grow? We run into the first of many of these delicious mysteries that surround this enigmatic fish. Even collecting the early life stages from the wild in order to research them is tough.
They're really rare, these early life stages, especially eggs. They have never been found in the wild. It might be a combination of little sampling where they are, and it could also be that they're not recognized as such. But I'm very puzzled. Why haven't anyone seen these eggs? Because there are fish egg surveys going on everywhere. And then when they get a little bit bigger, we start to see them a little bit more in collections, but they are generally rare across the world, which is so strange.
Confounding this mystery is yet another mystery. We have absolutely no clue how old molids can grow to be.
And I say that because aquarium studies have shown that mola mola has a lifespan or can reach like a large adult in about 20 to 25 years. So we do know they have a huge capacity for rapid growth. There's no question about it. But in the wild, there's one study on that sharp-tailed sunfish, that's one gene is removed from the molars, where some Taiwanese researchers looked at growth rings in the vertebrae. And I should say here that normal fish, you can age them by looking at the like little bones in the ears, so otoliths. And they have growth rings just like trees.
These bones, the otoliths, are a common way for ichthyologists, or fish nerds, to age many common fish. But the molids ain't no common fish.
I mean, that's a simplified version of it, but you get my drift here. They can sort of be aged based on these ear bones. Of course, sunfish don't have them to any extent that's useful, so their ear bones are described as chalk dust. I have never seen one in my life. I've looked and looked. They're so tiny. I've never been able to find one. And so even if you find one, they can't be used for aging. So we don't know how old molars are. When you see one, we can't age it at the moment. But some researchers looked at growth rings in the vertebrae, and same thing, fitted some growth models to this data. And their results were very different to the aquariums. So they predicted that a female sharp-tailed sunfish has a lifespan of about 100 years. So that's very different to the 20 to 25 years So we kind of have these two different studies, and they point in two different directions. So I don't know.
And so the question remains, are older sunfishes still just exploring life in their 20s? Or are they wizened elders who've been on this earth long enough to know some of its secrets? And does this apply to all sunfishes? Or just a few? Deliciously mysterious, indeed. After this unknown period of presumably rapid growth and development, they become the large swimming heads that we know, and hopefully after this episode, all love. Inside and out, the adults are strange. Their skeletons lack anything recognizable as ribs and definitely look like some kind of alien spacecraft. Most of their vital organs are kind of haphazardly bunched together, and layering on top of all of that, most of their mass isn't even muscle, but something similar to jelly. And they don't even have proper fish scales. It's like this fish is very bad at being a fish. So, a lot of people look at this weird, dopey-looking thing and just kind of assume things, like it's not fast or agile, and that maybe it's just a little bit dumb. I mean, certainly the fact that such a large fish typically has a brain the size of a walnut doesn't help that perception. I mean, an unshelled walnut, but still.
It looks like these fish shouldn't be able to swim. And that was thought up until the 1980s, I believe. People considered sunfish as part of the plankton community, like just very large bits of plankton. And plankton means something that kind of just drifts around with ocean currents. So people thought that they could steer, but that the locomotion bit was basically being pushed by the ocean current.
So that kind of begs a question. If all these initial perceptions are true, that mullets are big, slow, maybe just a little bit dumb, don't you think it would have gone extinct by now? I mean, if my high school biology courses taught me anything, it's that evolution ain't no fool. Survival of the fittest means survival of the fittest. Did the mullets cheat evolution somehow? The answer is, of course, no, they didn't cheat on the test. Because once you dig into what this fish actually is and what it can do, a whole world of intriguing superpowers and success as a species begins to unfold. So let's start that story with survival prerogative number 1. If you're alive, you gotta eat. Them's just the facts.
So probably the most common behavior is feeding, because everything out there needs to, make a living, and sunfishes work really hard for their food.
Even starting at just this basic premise of life, the mullets are super strange, because their diet consists of a large amount of things like jellyfish, pyrosomes, salps, things that are squishy, gelatinous, and mostly water. Not very nutritious by our standards.
And we know this stuff from satellite tracking, so putting a little computer device on a sunfish and then following what does it do during the day. And they look for what probably gelatinous zooplankton predominantly. This is all research points to that adult sunfish, they go for gelatinous zooplankton. And think jellyfish, salps, everything that looks a bit like a plastic bag in the water, that's what they go for. So Japanese researchers put like a wee cam, like a critter cam on the head of a sunfish to film how they feed. And it's fascinating. Imagine that the mouth is like a little round hole, much like a hoover, and they just go up to something like a jellyfish and they go and they suck it in.
If you look at a mullet's mouth, you won't find molars. Instead, their teeth, if you want to call them that, are all fused together in a structure remarkably reminiscent of a bird's beak. In fact, some reports of mola mola allege that they can't even close this fused plate teeth structure, partly leading to that dopey look and perception. So while they are a predator, they're less bitey and more slurpy. And here, again, something seemingly doesn't add up. How on this blue planet can these fish get so huge when, thinking about it, a gelatinous diet is extremely low in both calories and nutrition, lacking anything like protein or carbohydrates? It's like a basic tenet of any health and fitness class I've ever taken that you need calories and a variety of nutrients, from carbs to proteins to fats to micronutrients, just to be able to function and grow. This holds true for a lot of the animal kingdom, so what the heck, Molids?
And then in the throat, they have these teeth that they can control. They're like embedded in muscle, and so they can kind of think alien, like with sort of little claw in the throat that can help to grab hold of this jellyfish and like eat it. But they don't just do that. They will also spit it back out and suck it back in, so that they end up only eating the gonads, or the sex organs. What do you call gonads? And they don't eat the bell, for example, because that's mainly just water and there's not a lot of nutrition in there. So they can actually selectively eat the best part of a jellyfish. And you wouldn't think that when you look at a sunfish. All it has is this little round hole, and it doesn't really bite. Do you know what I mean? Like, it just sucks the stuff in.
These teeth that she's talking about, which you heard right, are in the literal throat of the fish, are called pharyngeal teeth. They help capture, shred, and otherwise process the captured prey. Functionally, you can compare these to kind of like the claws of a cat. Retractable and covered within the tissue of the throat itself when resting, but can spring forth at the fish's whims. The level and precision of this control not only helps keep the prey item caught, but it helps the molid find and eat the best parts of its food without wasting precious energy on digestion of less nutritious parts. I mean, they may have a small brain, but you can't not call that super smart. And there's more to their diet, too, than just how they eat their jello. Research within the last 10-15 years has been suggesting that a sunfish eats a bigger variety of food than we previously thought, including crustaceans and small fish, especially in the earlier life stages when rapid growth is more of a priority. One study looking at mola mola juveniles and subadults found that cnidarians, that's the jellyfish, made up only 16% of the diet of these young fish. Put that in context with the fact that for the longest time we thought that these sunfishes exclusively ate gelatinous organisms, and you can begin to understand why I'm excited here. Sunfishes might play a much, much larger role in the overall ecology of the ocean than we previously thought. And we still don't have too many concrete answers. Just another mystery. Much like myself, molids are incredibly food motivated, and the lengths, well, more accurately, depths, that they will go to for a bite is, in a word, respectable.
And they dive in what's called yo-yo diving behavior. So basically, they dive to some hundreds of meters into the mesopelagic.
The mesopelagic being depths between 200 and 1,000 meters, or between 650 and 3,300 feet, for those of us trapped within the confines of the imperial system.
And so they cool down when they're there, and then to warm back up, they dive all the way, or they come up to the surface, or maybe not all the way to the surface, but they can come to some layer that's warm. So what we call over the thermocline, basically. So this can be at 100 meters or 50 meters, or they can come all the way up to the surface. And so they come up to thermoregulate, basically warm up. And then when they've done that for a little while, they dive back down and search for food.
The repeated up and down, of course, being why it is called yo-yo diving. Interestingly, these dives don't appear to be super long. Due to the cold, deeper waters and the fact that these fish are still, well, cold-blooded, the average deep dive lasts less than 10 minutes before they have to return to the surface and warm up. And trust me, this is extremely cool, and that's for two reasons. One, this is one reason why the fish are seen laying at their side on the surface, so that they can put on some shades, grab a drink with a little umbrella on it, and soak up the rays of the sun. This helps their body temperature re-warm and re-stabilize before diving and doing the whole process again in a cycle of hot then cold. Cue Katy Perry.
That's what they do most of the day, dive up and down to cycle between warming up and then searching for food and feeding.
Secondly, though, this is an amazing superpower because there are not a lot of bony fish that are even able to do this kind of extreme, rapid, and repeated deep to shallow behavior. Molids are an elite few. To understand why, we need to deviate a little bit off course, talking sunfish specifically, and talk about general fish strategies for buoyancy, which means we sail once more into the realm of fish physics. One exciting new study has now quantitatively demonstrated fish physics to be 153% cooler than regular physics, with a p-value of 0.04. The authors of this study theorize that this result is largely due to the involvement of fish. Right, so most bony fish tackle buoyancy, how much they float or sink in the water, with this internal organ called a swim bladder. Much like how a scuba diver uses air in an external vest to help regulate buoyancy, fish with a swim bladder also use oxygen to fill and empty it, rising and sinking when doing so, respectively. This is really wonderful and quite brilliant for precise buoyancy control, but poses a problem when you would like to ascend or descend great distances quickly. The process of inflating and deflating the bladder can be relatively slow, and it involves a lot of blood chemistry. This ends up mattering a lot for the fish, because gases underwater will expand or contract quite rapidly from pressure changes as you move up and down in the water. Think about being underwater and blowing a bubble, watching it rise to the surface. It usually gets bigger as it goes upward, right? Less pressure on the gas as it goes up in the water means it has more room to expand, so it does. If that gas is contained in a vest on a human or a bladder in a fish, it provides more upward lift. The reverse is also true. More pressure as you go down means air compacts naturally, providing less lift. So just changing your depth with the same amount of air in storage will change how much you naturally float or sink. All of these principles hold true if you are a human scuba diver or a fish with a swim bladder. Pull a fish with a full swim bladder up too fast from too deep, that gas will expand inside the poor fish, causing internal organ damage, ruptures, and even death. Have you ever seen a picture of a blobfish, that poor, pink, slimy-looking creature with a perpetual frown? Well, it only looks like that at the surface because of exactly this happening. It looks quite normal down at the depths that it's supposed to be at. So, back to the sunfish. If you are looking to dive and rise under the span of 10 minutes per dive, well, a swim bladder with its slow blood chemistry-fueled gas adjustments, it just won't do.
And sunfish don't have swim bladders, and that is an advantage because they dive up and down in the water column all day, and having a swim bladder would be a nuisance because it would have to kind of get air out of it and then back in and out of it, to adjust the buoyancy. So that's not feasible. So that's presumably why they have done away with their swim bladder and instead developed this other form of buoyancy.
Just like a molid to not be content with the way other fish do things. So what is this mysterious other form of buoyancy? The answer to that lies, quite literally, just a little way underneath their skin.
Now, once you slice through that, underneath is a huge layer of collagen, and it looks the same as if you slice through a coconut, like that thick white layer underneath. It's beautiful, and it looks like it should be fat, but it isn't. It's collagen. And it creates a capsule around the sunfish. And it aids in buoyancy. And it probably also has some structural function whereby it's both flexible to some degree, but it makes the fish really rigid.
Fun side note here I can't resist. Many papers call this layer the capsule because of the way it encapsulates and kind of wraps around the entirety of the body of the fish. And honestly, I just love that. I can call a molid a capsule monster and still be technically correct.
So it's just because it has less buoyancy than seawater around it. So imagine it's like a big life vest, just not as buoyant as a life vest.
Instead of popping you to the surface, this vest's goal is to provide close to neutral buoyancy, and, unlike air, be incompressible enough to do so at any depth.
If a sunfish dies, it will sink to the bottom, so they are slightly negatively buoyant. So they do need to move to keep from sinking, but it is not very much. So that's the principle of it. They need to move incredibly little to stand still in the water, if you will. So what happens is that their dorsal and anal fins will undulate ever so slightly. And they don't flap them back and forth, but they undulate them. And that is presumably to just keep steady in the water. So when I say they're negatively buoyant, it's not very much. It's not like they sink like a stone or anything. It's just that if they stopped swimming, they wouldn't like pop to the surface. That they would sink to the bottom. So it's a very good design. A lot of people ask, are they dangerous? And generally speaking, no, they're not dangerous. Except when you dive with them. And it's not the fish. It's just because divers lose their minds and they will follow these fish into the depths. I don't know how much video footage I have of divers that have sent it to me saying, oh, here's, I saw the sunfish, and I can hear their computer alarm going off like crazy. But they have followed these fish into the depths because of just they're so fascinated. And the fish can move down in the water without you really noticing. And I have done this myself, staying level with a sunfish, and suddenly my computer is going nuts because they have ever so slightly just like a little alien spaceship, if you will, have got to just kind of lower themselves in the water, and you go with, and then you reach, your depth limit. They are absolutely excellent at staying still in the water. They have a very, very good control.
So that's eating. Survival prerogative number 2 after that is, not being eaten. If we rely on assumptions, you'd think that such a slow-moving, huge target wouldn't be a hard meal for a hungry shark or a orca. It's all too easy to imagine these slow fish easily being caught and noshed on, but to avoid this, the mola actually employs some weird tactics that are quite effective. And the first, surprisingly, is speed and agility.
And then now that we have so much underwater camera action, everyone on the planet these days have a camera, and many people underwater has, GoPros and things, and sharing what they see, that we have learned that these fish are underwater acrobats to some degree. So when they are smaller, and when I say smaller, I mean sort of, half a meter, they're super sippy. So when you see these underwater, and in California, you can actually see these seasonally. They seem to come into the shore, and they are so zippy. They sip around, and they can they can get out of the way very fast, and they can jump out of the water, and they can clear the water line and jump up into the air. When they get older, they get less and less zippy. So they take longer and longer to kind of accelerate, if you will. And you can see this when you dive with them and they get startled. It sort of takes, a few fin strokes before they gain speed, but then they are off. And so they are actually really fast.
Fast, meaning we have recorded burst speeds of mola mola going 6.6 meters per second, a shocking 14.8 miles per hour. For comparison, the fastest human swim speed seems to top out around 2.5 meters per second, or 5.6 miles per hour, just a little over a third of what a motivated molid can achieve. Some molids will even use this speed to breach out of the water, jumping into the sky up to 3 meters or 10 feet into the air. Of course, that's burst speed, mind you, but they also have endurance. Average cruising speed seems to be around 0.9 meters per second, or 2 miles per hour. So while our initial inclination might be that there is no way this giant, awkward swimming head can be fast, look a little more and you find some surprising truths. So, burst speed and agility is all well and good, but some would think that with such a small brain-to-body ratio, sunfishes just rely on basic fight-or-flight instincts. But would you believe me if I told you that the fish also employs some thoughtful strategy, too?
And so a study we did a few years ago here in New Zealand where we were looking at harassment of sunfish by orca. And I was trying to species identify all of these interactions that we had video of. And we as everybody else, we thought these orca were pushing the sunfish around and harassing them and kicking them up in the air and things like that. And at some stage, I was looking at a video and I went frame by frame. And I realized that what I had seen as pushing by the orca at normal video speed was actually the sunfish reacting prior to any physical contact. And I just could not believe what I was seeing. As the orca approached, it flipped so that the belly was out of the water and it was basically upside down in the water. And it happened so fast. And so sometimes they will do the belly thing upside down. Other times they will just basically keep the clavers or the back end towards the orca as the orca passes. And they will then swing around as the orca passes so that the back end is kept in the direction of the orca at all times. But it's like this platform is so efficient at changing directions that it kind of changed my whole view on that body form, that it is much, much more efficient than what we think when we just look at it.
Yeah, fast, efficient, and tactical. Literally the exact opposite of what people might think when they just look at a molid.
And I have heard, I am yet to read the research, but I have heard that this body form is exceptionally efficient. And so underwater robots are being developed based on the molar locomotion, like the system, because it's so efficient.
I, for one, welcome our new robotic sunfish overlords. I just hope they let me fight on their side when the fish AI uprising comes. In 2046, on March 31st, at 2:03 p.m. Okay, even with the speed and the smarts to avoid predators, you aren't going to avoid predation entirely. I mean, you do share an ocean with sharks, orcas, sea lions, etc., all of which are still faster and more agile than you. And we do see that these fierce predators will definitely take bites, but it's not very often. And if they do, sometimes they won't even finish the job, choosing instead to chomp down and leave the fish very much alive. So enter a third strategy for not getting eaten, literally being the most unpleasant meal you can think of.
Ooh, these are good questions. So the skin is something else with sunfishes. First of all, the skin is really tough, and secondly, it's really rough. They don't have scales, typical fish scales, but they do have scales, but they're modified. So when you look really close down, you can see these hexagonal shapes, and they are almost like fortified with bone material. They're really, really hard, and it's also full of little spiky bits. And I know this because when I collected skin samples from these fish for genetics, my hand slipped at some stage and scraped against the skin of the fish. And I remember being underwater and I was quite deep, and I looked at my hand and I thought, I have algae on my hand. There's this green stuff on my hand. And it turned out it was blood, and which is green underwater because the red has been filtered out. And so I was first time I had seen myself bleed underwater, and I was very fascinated by that. But I was also fascinated how easy it was to hurt oneself on the skin of a sunfish. And I have since heard people being rammed by a fish, and basically that has taken off the entire outer layer of skin, exposing muscle underneath. So the skin, the morphology of the skin with all of these hard bits, probably very effective against predators at sea.
The skin is incredibly thick, too. Reports range between 2.5 to nearly 8 inches of it. Coupled with the fact that there is a rather unappetizing layer of mucus coating the bone scales that aren't scales, this can often lead to a poor molid with a huge bite taken out of it, but still swimming around, very much alive. But then another question. If a predator has already gone to the effort and does have the equipment to eat mola, and if they've gotten through that unpleasant skin layer, why not finish the job? Are ocean predators actually aware of the sunk cost fallacy? As much as I wish that were true, it's actually all about that structure of collagen that helps with buoyancy, the capsule.
The bigger they are, the thicker the layer. And so if you imagine when you have a fish and you kind of just slice it open, if you want to eat a mackerel or something at home and you just slice it open to gut it, you can't do that with a sunfish. You have to kind of cut through this layer and then little by little sort of cut your way in by removing pieces of the skin. So presumably predators have the same problem if they want to get to the good stuff, which is inside the muscle and also some of the organs. They have to come through this thick layer of collagen, and also deal with that other rough layer of skin.
Interestingly, some sea lions get around this by going straight to the core, burrowing all the way to that huddled mass of the mola's interior organs and eating those, then simply playing with the rest of the body like a frisbee before leaving it for the detritivores. It's kind of like a McDonald's Happy Meal for the sea lions. Low in any actual quality nutrients, but hey, at least they got a fun toy out of it. Other than predation, there are other problems molids must contend with in their quest for living a healthy life. It may not be super appetizing to predators larger than it, but what about things smaller? Strangely, one of the more potentially significant health issues for molid species is the insane diversity of parasites that live on, in, and under the fish's skin. I do not kid when I say that molids have so many parasites that even their parasites have parasites.
So they have an extraordinarily high amount of parasites, both inside and outside.
This could be for a number of reasons, but the fact remains that more than 40 known species of parasites have been found to reside on mola mola alone. Concrete studies on the effects that these parasites have are few and far between, but being a parasite breeding ground could cause any number of theorized issues, from choking them out around the gills to infections to general unpleasantness. I mean, I wouldn't want copepods and worms laying eggs in my skin or eyeballs. So, to combat this, they employ a unique variety of behaviors.
So the ones outside, they can get help from cleaner fish. And in Bali, obviously, it's a very famous area for seeing sunfish during cleaning. And they come in to the reefs there at depths where divers can go. So you can see them at 20, 30 meters depth. And they come in and they have this fascinating behavior where picture being on a reef and you can see a whole heap of reef fish and they don't want to come off the reef because the reef is their home and their safety. And then you see this massive sunfish, like a food truck full of parasites, come into the reef. And it doesn't want to come into the reef because that's a bit dodgy for the sunfish that likes open waters. So there's like this negotiation that happens when it comes in. The cleaner fish would like to come out to the food truck, and the food truck would like to come in, but not too close. So they find some middle ground, and the fish come out from the reef, and the sunfish somehow signals to them by turning the head up. So imagine it's almost like Jesus on a cross, two massive wings out to the side and then the head up. And the sunfish will be super still in the water, and the fish will come out and they will clean it, and it's beautiful. It's like a little cloud of fish around it. And the sunfish actually close their eyes. They have this massive thick membrane that they kind of draw over their eyes to protect them from the cleaner fish that come in and pick. So they can't see you. And so you can actually, I mean, I got really good at sneaking up on them because I tagged them with satellite tags. And as long as the cleaner fish stay, they seem to take cues from the cleaner fish that everything's okay. And if you swim up to them, and many, many divers do this, the reef fish will freak out and they will disappear and back into the reef. And the sunfish will just go, this is not for me, and it'll just swim off the reef.
So, to all my diving friends out there, please make sure to keep your distance if you do happen to see this amazing sight.
But they do other things also. Some of these parasites are really big and probably beyond what a fish can eat. So they will come up to the surface and present themselves to seagulls, or in some areas, some albatrosses, I believe, have been seen picking off parasites, and they will then have a little spa session there.
Basking at the surface to warm up from deep dives, turns out, has an added benefit. It's an open invitation for seagulls and other birds to come peck at the free parasite buffet. Tasty. There are those in the molid world, too, that theorize that trying to dislodge parasites is a key reason that they will breach, causing a huge splash on touchdown that may help clean up their infested surfaces. All of this so far has been about the survival of the individual fish, but success as a species means that you also have to successfully reproduce. And I hope you like more mysteries, because while we do know a little bit about, well, the seals and the eels, so to speak, as they apply to molids, there is much, much more that we just don't know. But first, let's talk about what we do, or at least what we commonly theorize. Many believe that sunfishes are very reproductively successful simply because, well, they play the numbers game. That is, they lay an insane amount of eggs, hoping that even a small percentage of them will survive, hatch, grow up, and become adults to continue the cycle all over again. But the exact numbers?
Well, it's difficult to say exactly because we can't even gauge what type of creature this is. So when you look at one female, they have an enormous amount, hundreds of millions of eggs when you look at an ovary. So we don't know how many eggs they spawn per season. We think that they spawn several times during a season. We don't know how many eggs they spawn in total. So the actual fecundity is not known, but it's presumably very high. Normally, we would sort of take a manta ray, for example, and we know they have a very low reproductive rate and they live for a long time. And so they kind of go down into one end of the spectrum where it's sort of slow growth, old, low reproductive. And then the other end of the spectrum, you have these short-lived species that reproduce early and reproduce a lot. So when you look at that spectrum, where are we supposed to place sunfish? We know they have a high reproductive potential, but how long does it take them to reach an age where they start to reproduce? We don't really understand that. We don't understand, are they long-lived or are they short-lived? Because those two studies we have point in two different directions. And because we have difficulties aging them, we can't really tell when they start to reproduce either, like how long does it take to reach that size. So we don't really understand what type of creature it is. how they spawn, we don't know. Do they come together, one male, one female, or do they have any kind of spawning behavior or is it, just like a huge amount of sunfish coming together? Is it shallow? Is it deep? Is it near shore? Is it offshore? We don't know.
All these unknowns might be enough for any fish biologist to just throw up their hands in frustration. Or buckle down and lean into the excitement of it all.
And what's even more deliciously mysterious is when we look at the 3 molar species and then we look at the sister genus where we have that sharp-tailed sunfish, their larvae are found quite often, for example, in the Sargasso Sea. Same with the species that sits one genus further out, which is called a slender sunfish. Their larvae are quite common. So what is it about the molars? They're just totally hiding.
Despite all of these mysteries, when we put a few of the puzzle pieces together, we arrive at this vision of a fish that is really, really successful, not in spite of its uniqueness, but because of it. It spends its day yo-yoing up and down, not something a lot of fish can do, to selectively eat the best parts of a food source that is abundant and not many others will go after, due to its toxic stings and poor nutrition. It can eat a lot of things, and it avoids getting eaten by being, well, generally gross and hard to chow down on while still being relatively fast and clever. It forms partnerships with other species to enjoy a lovely spa day and feed reef and avian ecosystems. Honestly, there is so much to respect when it comes to the importance of this weird, underrated fish. Hardly the vision of a useless, dopey animal that evolution played a cruel joke on. Now, this is the part of the podcast where you might be expecting me to come at you with and they are super endangered and we need to protect the precious few we have left. But honestly, that may be a little much.
And so with climate change, where there's a lot of range shifts going on with species that are moving south or north, depending on where you are on the planet, sunfishes will presumably also have these range shifts. But I am hopeful that because they have such a, it looks like their thermal tolerance is quite wide, and they can, regulate their temperature in all these different, by using the water column, that they may fare relatively well compared with other species that have a much smaller thermal tolerance. So I think we will see some shifts, but I do think that they will fare better than other species. Not all species, of course. There are other species that can do this as well, but they are not in imminent sort of danger of losing their core habitats as far as, and this is very contentious, and not all people in the molar world agree with me on this one. But I think that's part of their superpower.
Don't go taking that out of context now. Emissions are still not good, okay?
And the other thing is that they're not super palatable. So they're not fished. And those two things combined will probably mean that they will fare fairly well compared with other species.
That is to say, molids aren't exactly super fished commercially. Humans do love eating weird stuff, though, so it's a never say never sort of situation.
I would say that probably depends on the culture, because I think in parts of Asia, it's really appreciated as a meat. The Western palate, not so much. So what I do know, I've unfortunately never tasted myself, but I would like to try one day if I get the opportunity. But my understanding is that for sharp-tailed sunfish, that's they fish that quite a lot in Taiwan, and the intestines are eaten as a delicacy. And I should add here that sunfish have a very long digestive system. So they don't have a proper stomach. They have just one long tube from mouth to back end. and it's very long, and it is super muscular. So when you look at what's edible on a sunfish, the best muscle is probably the intestine, because the muscles that power the fins and movement is quite gelatinous. And apparently it reduces quite down when you cook it because all the water comes out of it. So the amount of fillet you get from a sunfish is quite small. So the intestines are rinsed out and eaten in Taiwan. A friend of mine also just went to Taiwan and sent me pictures from the fish market of a bucket of eyes. Now, how they are eaten, I don't know. I don't really want to know. And then I also believe that there is a type of street food where they take that big collagen layer, the skin from the skin layer, and they do something to it, and then they eat that. I'm not sure what it is, but it's some kind of preparation, and it turns into these slippery, it looks to me like, if you eat the core of an aloe vera, that slimy core, it looks a bit like that.
I mean, I'll try anything once. There is also the issue of it being caught in operations that aren't targeting it to begin with.
We do know that sunfish are taken across the world as bycatch in a variety of fisheries. And what we don't know is to what degree and where and in what gears. So we know they're taken on long lines, surface long lines in particular, and also in trawl gear and purse seine. And there is, I would say, how can I say this? There is a lot of information out there that's held locally by fishery departments and fishery management organizations. But it's often on it's on like a sunfish level. So we don't know what species it is, nor how big each individual was, or it's held as weight, and we don't know how many individuals were involved in that weight. So there are many challenges in getting a hold of the data and then making sense of it to try and understand if fisheries bycatch is an issue for these fish or not. And so just to kind of, like many other species have this problem, but sunfish face one that is unique to them, in my opinion. And it is that if you, for example, have a data point that says a ton of sunfish were caught, you don't know if it was 1,000 small ones or one big one. And that is a big difference there. Were they little babies being fished up, or was it one big mama? We don't know. And those two things are very different when you assess the impact of a fishery on a species. So it is very difficult to infer anything other than, sunfish are caught as bycatch in this fishery.
Yet another mystery and another unknown. Still, it highlights the importance of good data collection and the importance of the work Dr. Nyegaard and so many other scientists do on a daily basis. There are so many mysteries of the delicious variety that surround this amazing fish, and with each step we take, each study we perform to unravel them, the better equipped we will be to protect the molids and the ecosystems that they are integrally tied to well into the future.
Yes. Well, they are hard to study. I can't deny that. So I would love to solve the aging. I would love to do that. It would just mean we would have a better handle on what kind of creature we're dealing with. And the other thing I would love to know is, where are all those larvae? And if I had three things, I would love to know the spawning behavior. These are the things that I just would love to know. And I have this philosophy that you have to follow the sunfish, because somehow my whole experience with these fish has been, if you follow them, they will I mean, not show you the way. I mean, that is taking it a bit far, but often things just kind of work out with them. So you just got to follow the sunfish, and they will reveal. I believe they want to be studied. They want to be considered. They've been such an overlooked fish for so long, and they still are in many ways. They're very comical fish. People sort of don't take them very seriously. They're not really considered. I mean, I've been to conferences where people have sort of said to me, "You and your sunfish," as if it's like a joke to study them because they're not real fish. They don't really factor in like serious research, you know. So I do think they want to be part of the global marine community.
That's all for today's episode of Bio-Diversity. Absolutely huge shout out and thank you to Dr. Marianne Nyegaard for both taking the time to be interviewed and acting as a consultant and fact checker for the show. It was an absolute pleasure, and I hope that your enthusiasm for this amazing group of animals is contagious well beyond just me. Remember, you may not be to everyone's tastes, but just like the mola, your own uniqueness is an incredible strength. So get out there and own it, you crazy fish, you. Thanks for listening, and I'll see you next time. Oh, hey, sweet. You're still around. Alright, if you're a nerd like I am, it is highly likely that you've been screaming at me. Actually, there is a Pokemon that is a Mola Mola. And you're right. Generation 5 introduced Alomomola, and it is, objectively, fantastic. Much like the real fish, a lot of folk give undue hate to the beautiful Chansey of the sea. But if you're interested, maybe you can come join me over on my Patreon, and let's talk about it, yeah? Why is the existing Pokemon actually amazing? How would I design a more biologically accurate Alomomola? All of these topics will be in a short little bonus episode, exclusively for Patreon subscribers. I hope to see you there.